Hey, Math One. I wanted to go over a little bit of what we did in class today. A couple people were absent. Some of you had some internet problems, so I wanted to make sure you have what you need here. So, um, a reminder that I said this in class. Any late work that you have is due by Friday, 12 o'clock. That's lunchtime, noon, um, to get credit. After that, it's too late. Okay, and I know that last year a lot of teachers would say that, and then you'd have more time and more time. Like that's not happening this year with me. So I'm going to email you so you know exactly what you're missing. You'll get that email either this evening or at latest tomorrow after school. I'll try to get it to you this evening if I can. But I mean, you can look at PowerSchool and just see what's missing. Also, what we're going to do in this video is I'm going to go over some of the answers from the 1.2 homework. There was some confusion, and I want to help straighten that out. And we have a new assignment that's posted on Classroom, and I want to look through that with you and do a few examples. So mostly we're doing what we did in class, but this video can be really good for you even if you were in class. Maybe you didn't get everything that I was talking about. It's another opportunity. And the video is not going to be too long. I'll keep it brief, sort of brief, because, I like talking about math, so sometimes I get carried away. But let's look at 1.2. So it was interesting to uncover some misconceptions we had. What happened here when we looked at this f of 5 um, was some people thought that that meant 5f, and it doesn't. So when you see f of 5, that means put the 5 into the equation. In place of the variable. Okay, so it replaces the variable. And that's all this means. In fact, we could have written y equals 8n minus 3 and said find y when n equals 5. Okay. But instead, they used this notation. They said f of n equals 8n minus 3. F of n is sort of a fancy way to say y, like the letter y. And so if they want f of 5, then they want you to replace the n with a 5. So that's 8, and then instead of an n, we're going to do a 5. This is 8 times n. That's what 8n means. So we're going to write it 8 parentheses 5, because that means 8 times 5, and that's how most people write it. And then we'll do minus 3. You have to do multiplication before you do subtraction. So we're going to write our f of 5 again. That equals 40 minus 3. And no calculator, use your fingers if you need to. You can count backwards from 40, and it equals 37. So with that being said, let's take a look at number 2. Oops, you can't see that. Let's take a look at number 2, which asks us about g of 5. Now, if you didn't do this one or you did it wrong, I think you should pause right now and try it based on what we just did. They said g of n equals 3n minus 10. Remember, g of n is just a sort of fancy way to write y equals 3n minus 10. And what g of 5 is asking is, what is y when n equals 5? That's an n, sorry, when n equals 5. Okay, so here we go. G of 5. We had 3n minus 10. So we're going to do 3. We're going to replace the n with a 5. That's 3 times n. So I wrote 3 parentheses 5 minus 10. 3 times 5, we all know that's 15, minus 10. G of 5 equals 15 minus 10. So G of 5 equals 5. Oh, that's cool. It's like 5 and 5. G of 5 equals 5. That's it. And I don't even know if I assigned number 2, but that was a good one to practice on. And I think that's enough to kind of get you going there. Then I want to look at number 9, because we went over number 9 in class. And it's on page 8 still. And number 9 wanted us to complete each table by looking for the pattern. And then in the directions I gave you, I also ask you to write an equation. So what we have here for number 9 is, if you look at this, I think most people realize that it's times 2, times 2, times 2, times 2. So you'd have to do 32 times 2. 2 times 2 is 4. 2 times 3 is 6. So you would put a 64 there. I'm going to put it here because I don't want to write on this book. And then if I needed to find the 7th term, I would do 64 times 2. 4 times 2 is 8. 6 times 2 is 12. So that gets me 128. And again, I really want you to do these without a calculator. It's good practice. Okay, 128 times 2. 2 times 8 is 16. Carry your 1. 2 times 2 is 4. Plus 1 is 5. 2 times 1 is 2. 256. So my 6th term is 64. My 7th term is 128. And my 8th term is 256. Now, what about writing an equation? Well, to write an equation for this, we actually don't really have the setup for that yet. You might remember from last year. But for now, let's just write it like this. We're going to say, if you want the answer, you're going to take the previous answer. Previous means before. The previous answer. And we're going to multiply it by 2. That is our equation for number 9. If you want the new answer, you multiply the previous answer by 2. If I wanted to know what the 4th term was, like pretend I didn't know, I would have to take the 3rd term, 8, and multiply it by 2. That's it. Now, number 10, we can write an equation for. So probably you figured out that this is minus 16, minus 16, minus 16. 18 minus 16 is 2. 2 minus 16, well, this is a positive and a negative number. So we're going to subtract 16 minus 2, which gets us 14. But the big number wins, so it's negative 14. Now we have negative 14 minus 16. These are the same sign. So when they're the same sign, remember, add, subtract, if they're the same sign, they stay the same sign. So they stay negative. Because it's like I lost $14, I lost $16. If I add those together, I lost 14, I lost 16, that's 10, carry your 1, 30. Okay, so that's minus 30. And then negative, oh, you couldn't see that, sorry. That's where I added 14 plus 16. And then negative 30 minus 16, add those two together, I'll get negative 46. Oh, I didn't have to go that far. Wait, I'm on the wrong one. There it is, negative 46. I knew it. So 66 minus 16 is 50. 34 minus 16 is 18, and so on. But then we were supposed to come up with an equation. So hopefully you looked at your work from last time, and you saw that last time I gave you guys an outline for how to write an equation for these kind of problems. First of all, you have to know your rate of change. I write ROC for rate of change because I think it's kind of cool. So you have to know your rate of change. And on this one, my rate of change was minus 16. The other thing we have to know is the initial value. And that's the zero term, or f of 0. Well, if we look, they gave us the first term, but not the zero term. So let's think about this for a minute. I know that I have here, let's see, the first term, 66, next term is 50, third term, 34. So it's like minus 16 every time. So the zero term, it's got to be something minus 16 equals 66. So how do we find this? We do the opposite. Or what's called an inverse operation. What's the inverse operation to subtracting 15? Adding 16. So if I want this number, I do 66 plus 16, 82. Because 82 minus 16 is 66. So I just found my initial value, and that is 82. Now, if you look at your notes from the last class, it was like a Nearpod that we did together as a class. One of the things that I showed you was if you want to write an equation, you can write f of x equals, and we're going to fill in the blank, the rate of change times x plus the initial value, which is the zero term. Well, we have our rate of change, negative 16. We have our initial value, 82. So our equation that goes with number 10 is f of x equals negative 16x plus 82. That's our equation. The other part of your assignment was these exponent problems. Let me zoom in a little bit here. Something I noticed when I was looking over folks' homework was that some people didn't read the instructions. Instructions say write each expression using an exponent. So you didn't actually have to figure this out. In fact, they wanted you to do the opposite. They wanted you to make it easier. So if I have 6 times 6 times 6 times 6 times 6, that's 6 times itself 5 times. And in math, we can write that just by saying 6 with an exponent of 5. And how we say that is 6 to the power of 5. Right? The 5 is like a power up. And 6 to the power of 5 means 6 times 6 times 6 times 6 times 6. So then you can probably guess what 18 is going to be. 4 to the power of 3. Okay, and I'll let you do 19 on your own. I don't think you need me for that now. And then expanded form. So 21 was kind of a trick question. 7 to the power of 1 means 7 times itself 1 time. You know what that is? 7. Easy. So easy that it was hard. Then number 22, expanded form means you want to write that 3 times 3. So we're going backwards. And then you want to write what it equals. Equals 9. 23, the expanded form is 5 times itself 3 times. 5 times 5 times 5. And then you multiply that out. I'll let you do that. And you get 125. That's it. I hope that makes sense. That's a little review, right? You've done exponents before, probably. So that was the 1.2 stuff we went over. Then we jumped into 1.3. We've already seen this pattern, so we didn't spend very long on it. We just spent long enough on it to remember that it was times 2 every time. So 3 times 2, we got 6. And then 6 times 2, this ended up being 12. 12 times 2, this ended up being 24, and so on. So we talked about how can we write an equation for that. Well, the same way we did on the last assignment is that we can just write for an equation, for now, we can write that the answer, like the answer that we want now, equals the previous answer, which they call a term, the previous answer, times 2. That's it. So that's all we have to do for this kind of equation, and it's called a recursive equation. And the only thing you really have to know right now about that word recursive equation is a recursive equation means you base it on the previous answer. It'll make more sense when we move on to other things. So I gave the assignment, and the assignment's going to start with number 7. And I think you guys are going to be fine with these, so I didn't show you those as an example. I thought, hey, let's jump to number 11 and see if we know what to do with number 11. See if I can turn the page. Oh, I wrote in my book. Oops. I mean, you can write in your books. I was trying not to write in mine. So number 11 says, the value of the 4th term is 80. The sequence is being doubled at each step. Doubled means times 2. Here's the explicit equation. And here's the recursive equation. So if we know the 4th term is 80, and we know the sequence gets doubled every time, if we want the 5th term, we can just look at the previous term, the 4th one, multiply it by 2. And you would get 160. Okay? That's about all I showed anybody for these. I want to kind of see how you do on these. Now for 13, 14, 15, these are going to be a little challenging, but I'm happy about that. And I said no calculator because that's how I am. So I'm going to copy 13 onto the other paper so I can write kind of as big as I want. And you probably want to do these in your graph notebook. So it's 13 is 4 to the power of x. And then they made an input-output table or an XY table with 1, 2, 3, 4. I think they went all the way to 5. Yeah. So if x is our input, then I'm going to put that 1 in for the x. So that means y is going to equal 4 to the power of 1. I replace the x with a 1. And then here is going to be 4 with an exponent of 2, because the 2 is supposed to be inputted for the x. 4 to the power of 3, and so on. So any number to the first power is just itself. 4 to the second power, now that's not 8. It's because that's 4 times 2. 4 to the second power means 4 times 4. And I think we know that's 16. 4 to the third power is 4 times 4 times 4. Well, we already know that that's 16. So that equals 16 times 4. And in case you need a little help with that multiplication, you haven't done it in a while. 4 times 6 is 24. 4 times 1 is 4, plus 2 is 6. So you get 64. So now we have 4 to the power of 4. That's 4 times 4 times 4 times 4. Well, I already know 4 times 4 times 4 times 4 is 64, because I just figured that out. And it's going to be times 4. And again, one more time to go over the multiplication. 64 times 4. 4 times 4 is 16. 6 times 4 is 24. Plus 1, 25. Okay, and then you'll finish that. And you're supposed to do these other ones also. Okay. Sorry I missed you in class, or sorry if you were having trouble with your internet, but I'm glad you have this video, so you're good to go on anything you need. Bye-bye. I hope this recorded. If it didn't, I'd have to do it all again. Oh my gosh. Here we go. Please record. Please record.